My name's Sam. I'm a software engineer and I've been doing this for about 10 years. And that entire time, I've been working with APIs, whether it's using them or writing them myself. So they're a pretty fundamental part of being a coder or a software engineer. And I'm here to talk to you about what they are, different kinds of them, and how they work. So we're going to start with defining APIs. Then we're going to talk about three different kinds of them. We're going to talk about libraries, web APIs, and remote procedure calls. I do have some code examples just to demonstrate different ways these things get implemented. Valerie is going to be monitoring the chat, so if you have any questions for me as we go, please submit them there, and I will also have time for questions at the end. So before we can get into APIs, I want to talk about software interfaces. And when we, as engineers, write software, we usually want our programs to have some sort of interaction with the user. And a lot of us are familiar with different types of interfaces like graphical user interfaces, which might be an app on our phone where we're clicking things with our finger, might be a website we're on and we're using our mouse and keyboard to interact with it. There's voice interfaces. Back before smartphones, you might have had to call, the bank and verbally say your bank account number, and it would, tell you your balance, things like that. There are command line interfaces designed for humans to use in a terminal or a command prompt, and they're typing out commands. And all of those are for people to use, and there are special types of interfaces that are designed for computers to use, and that's what we call an application programming interface. So an API is designed for computers to interact with other programs while they're executing their own code. I have a graphic here just sort of demonstrating that all of these different types of interfaces um, expose certain parts of software to different users, and they all kind of fall under this software interface umbrella, but they're sort of distinguished by who is using it or what is using the interface and how they're interacting with the software. So just keep in mind, an interface is the sort of publicly available part of code that someone has written. As I mentioned, an API allows programmers to use code written by other people in their own programs. And this is really the most kind of important part of an API because, writing code is complicated and a lot of programmers face the same needs. So it makes sense when someone can share code they've written, and that saves you time and effort of making sure you've implemented something correctly. We're going to talk about different examples of APIs, and that will make more sense about sharing code. But beyond sort of the core concept, it allows programs written in different programming languages to be used together. Some programming languages are really good at certain types of tasks. And using an API, you can enable those tasks with other languages. For example, the C and C++ language is really good at doing, operating system level process management, like managing threads and working with your central processing unit. Whereas a programming language like JavaScript might not, have access to those internals, but might need access to them. So using different APIs, you can get access to those processes using your language of choice. So when you write an API, because it's meant to be used in code, it typically includes documentation. And hopefully you have a really mature API and they have a complete how-to guide that might include how to install it, version, history, a place to ask questions, uh, and maybe even some code examples. But at the very least, you should get a description of the available functions, their inputs, their outputs, and any errors that you might run into. We're going to see a couple of examples of documentation later. As I mentioned in the agenda, we're going to talk about 3 different types of APIs. So there are libraries, there are web services, and there are remote procedure calls. And we're going to jump into libraries. So a library is an API that's packaged into executable code, and you import it into your software project to use it. That means you physically have a copy of that code running on your machine alongside the code you write. Common use cases for this tend to be really stable things that change infrequently. Because you need to uh, physically retrieve that executable every time there's a change, you don't want to have to go through the process of upgrading too frequently. So that's why these stable common use cases make great libraries. So things like file system operations, like reading input from a comma separated value file or saving text to a file. Mathematical functions. We're going to see an example shortly about using fractions in the Java programming language. We as people know everything there is about doing arithmetic with fractions, but they're not built into the regular Java programming language. So um, instead of every single person who wants to use fractions coming up with their own implementation, we're going to use a library that someone else has written to handle fraction arithmetic. Data processing, so that could mean, retrieving data from a database or some other data source, doing data analysis on it. There's a popular uh, data processing library for the Python programming language called Pandas, and then logging is a popular uh, library use case. And logging is when we sort of write code or write text to a file about the execution of our code, and it can help us in debugging. So how do we use a library? First of all, the library developer needs to write the code. And after they write it, it's critically important that they test it. And when we write our own code, we're testing it, and we're pretty sure it works. And if it doesn't work the way we thought it would, we can change it. But when you're writing a library, um, as I mentioned, it's cumbersome for your users to update. It's really important that your code works the way you say it will, because your consumers are going to trust you to have working code. After you've written and tested your code, then you're going to package it and distribute it. So, that could, if you're a Java programmer, that might mean making a Java jar file. If you're a Node JavaScript developer, maybe you're making a Node module, could be a Python library. Somehow you're packaging it and creating a executable binary file, and you have to put it somewhere where people can find it. Sometimes that's just GitHub, and you can use GitHub's release feature. There are repositories that collect all sorts of libraries for people to search through and host the distribution of them. We're going to see an example of that later as well. In the fraction example, the developer of that library self-hosted on a website. So it just, by distribute it, I just mean publicly make it available. After the library has been published, the consumer needs to acquire the executable. In our example, we're going to see I download the file, and I'm on Windows, so it goes into my downloads folder, and then I'm going to tell my Java runtime about it. but when you're using a lot of different libraries, manually downloading all of them and keeping track of versions can be kind of a pain. So there's a special kind of software called a package manager that sort of automates the retrieval and linking of software libraries. So we're going to see some of those too, but popular ones across different programming languages would be pip for Python, npm for JavaScript, Maven for Java, Ruby gems for Ruby. That's another thing I wanted to mention. API is not a specific technology. It's not tied to a specific programming language. All programming languages can interact with APIs, and it's just sort of this general term for the interface between someone else's code and your code that you're writing. So after you have acquired the executable and told your runtime about it, the last thing to do is import the library into your file, and you're ready to rock. You have full access to all the public classes, methods, objects, whatever has been exposed to you. And you use it exactly the same way you would with code you've written yourself. And as far as knowing what to do with that library, that's where the documentation comes in.
I have a question for you real quick, Sam. Are there certain, in your experience, certain languages or libraries that have better documentation than others? Like, are there some that aren't done very well and some that are done really well, in your opinion?
Yes. So what we're looking at right now is a website by an open source collective called Apache. And, the more like financial support and more people working on a library, you tend to have better documentation.
Okay.
And this is not demonstrated in this presentation, but there are ways that you can automate the creation of documentation.
Okay.
I know Java has that capability in JavaScript also. In here, we see the word JavaDoc. That's a popular format with the Java programming language where you add annotation to your code, and when you compile it, it automatically generates documentation for you.
That's
So
nice because then it keeps it consistent for people.
exactly. So
Okay.
most people who are releasing public documentation, try to use these automated documentation generators, but you only get out what you put into it. So some people are
Right.
stricter about it, some people are less strict. And if it's one person working on it and it's a passion project, they might have good documentation, but maybe they're really busy and they just kind of have a bare bones readme on their GitHub. So
Got
it,
it.
it definitely varies, and in practice, I think it's generally better to use bigger, more popular frameworks, just because they'll have more people testing them, they'll have fewer bugs, they'll be more secure, hopefully,
Yeah.
because that is a big concern. We're going to see that in just a second. Security, when you're executing other people's code that's
Yeah.
precompiled, that can be scary. So that's why I sort of trust bigger open source projects.
Cool. Thank you for the sidetrack.
Yeah, good question. So, like I mentioned, I want to be able to use fractions and do arithmetic with them in my Java program. So we're looking at the homepage for a library called Apache Commons Lang. And this adds some common utilities for the Java programming language, some string manipulation methods, and some basic numerical methods. And one of those numerical methods is the concept of fractions and doing arithmetic with them. So as I mentioned, step one, the library developer writes, package, and distributes the code. So they've written the code, they are big enough that they host their own website, and they have all sorts of great information. But the next step was for me, the consumer, to acquire the library. So I went to the download section of this website. And as I mentioned, it can be kind of scary, just arbitrarily executing code you find out on the internet. So the Apache language provides both a binary, which is the compiled code, or I can download the source code and compile it myself. If you do the source code, then you can, look at it, make sure there's nothing nefarious in it, but then you also have to go through the step of compiling it yourself. So I did download the binary, and they offer a zip file or a tarball. I'm on Windows, so I took the zip file, and it went into my downloads folder. These are screenshots from an integrated development environment, an IDE called Eclipse, and it gives me a graphical user interface for adding modules to my class path. So I have this Commons Lang 3 jar in my downloads folder. I mentioned the Java doc earlier, so that's included in here, and sources is also included, which will allow me to view the source code in my IDE, even though this has already been compiled into bytecode. Once I add that to my class path, it shows up in my referenced libraries, and I know I'm good to go. So inside this package, there's a class called fraction, and it's in org.apache.commons.lang3.math. So the last step, I get to use it. So I import that class we just looked at, and then I have access to all of the public methods. And I use it the same way I would with code I've written myself. So int is a built-in data type in JavaScript, or in Java, and when we declare a variable, we give it a type and a name, and then we can assign a value to it. So int is the type, 1 is the name, and I'm assigning it the value 1. Down here, I do the exact same thing. I give it a type, fraction, I give it a name, 1/2, and then inside the fraction library, there's this get fraction method, and I'm passing in 2 arguments here. How did I know to do that? Well, we go to the documentation. This is a screenshot of that Java doc I was telling you about. So it has the name of the function, get fraction. It lists the arguments I need to send in, and then it gives me sort of a high-level overview of what it does. So this get fraction method creates a fraction instance with the 2 parts of a fraction y over z. And then it sort of gives me this reminder that if either one of those numbers, the numerator or the denominator, are negative, when it returns the fraction, it will be assigned to the numerator. Then it also gives me a description of what the parameters are. So the first number I pass in is the numerator, or the top number of the fraction. The second number is the denominator, the bottom number of the fraction, and then it shows what it returns. So if we go back, this method returns a fraction, so I'm able to assign it to 1/2 because that is a fraction object. The other interesting thing here is that it throws an arithmetic exception. So it gives me a little reminder, don't pass 0 as the denominator, or else I'm going to get this runtime exception. Same thing for the smallest possible integer value, which is a pretty big negative number. So I mentioned I wanted to do arithmetic with this. I don't have this displayed, but I can, built into the fraction class, there is a multiply by method, so I can multiply 2 fractions. So just the way I would call a method I've created myself, I have access to that because it's a public method. So with libraries, the tricky part is just, getting the executable into your project, but then it should be pretty easy once you've done that. it should feel very natural. This is a snapshot of a website called libraries.io, which just sort of shows a collection of major library repositories. So most programming languages that support the usage of libraries have some sort of central repository, and this sort of collects metadata about them and shows how many packages there are. So while I did go to Apache's website, I could use Maven. They have a repository called Maven Central, and they also have a package manager called Maven. And I could have automated the retrieval and the linking of that library if I wanted to use Maven. And the more dependencies you have, the better of an idea it is to use one of these package managers, just because it helps define all your packages in one place. You know what version you're using. Package managers also can tell you when there's an update to your version or if there's like a security vulnerability. So I think all of these are pretty obvious what programming languages it goes with. There's like Conda and PyPL are for Python, NPM's for JavaScript. Then most of the other ones are pretty kind of include the programming language in the name. All right. One last thing, there's a special kind of library called a framework. And it's very similar to a library, but it's more intended to be extended rather than used directly. So you follow the same steps, you acquire some executable, but instead of using it directly out of the box, you might, you know, using object-oriented principles, overwrite the objects that come from the framework. So Spring is a popular Java framework, and they have frameworks for doing pretty much anything that you would want to. You can make standalone desktop apps, you can make web applications. This symbol on the right here is for React, which is a popular JavaScript framework that was originally created at Facebook, and you can use that to make applications that respond to data dynamically and create kind of custom HTML elements. So with either of these, we could sort of write a .html file and spin up a website that way, or we can use these frameworks and extend the functionality that we get with them to make these special more interesting web applications. But sometimes the word framework and library are used interchangeably, but in my mind that differentiation is libraries are kind of used out of the box and a framework is extended. The next type of API I'm going to talk about are web APIs and web services. So as the name implies, these expose code over the internet, and they follow a request and response format. So a client makes a request to a server, which acknowledges it and then responds. And these are perfect for applications that are backed by a database or some sort of data source. And we call them CRUD applications. CRUD stands for create, read, update, and delete. So, basically any web app that we use, think, Instagram, I want to upload a new picture, I'm going to create one. I want to view my friends' reels, that's read. I want to update one of my pictures and add, tag a friend, or maybe my friend, tagged me and I want them to, and I'm, not looking very cute in that picture, I want them to delete it. So any sort of application where we're having data and we want to, be able to manipulate that data or retrieve it is going to be a perfect use case for a web API. There's lots of different types of APIs. And I'm going to talk about 3 of the most popular ones that I've all used professionally. Um, and I'm not going to go deep dive into the difference between them because they all kind of serve a similar purpose. But I'd say by far and large the most popular at this time is a REST service, and REST stands for Representational State Transfer. And REST is not a specific technology; it's kind of a architectural style and refers to a philosophy of how we want to expose all of these CRUD operations. SOAP is stands for Simple Object Access Protocol, and it can do the same things REST can, but this is a standardized web technology. It's governed by W3, the same organization that governs HTML and all sorts of web technologies. So this has a very specific meaning, and you have to adhere to its implementation. Just like React at Facebook, they created a new technology called GraphQL, and this is a query language and a runtime engine. So it allows us to ask for specific pieces of data or manipulate specific pieces of data, and we'll get to see an example of what I mean by that. But it also uses a internet protocol called WebSockets, which allows for live two-way traffic. So when I mentioned a web service makes a request and then waits for a response, GraphQL does that, but it also, the client can get pushed updates from the server without asking them. And that lets us do things like have real-time data get displayed, and we can do things like create messaging apps, or see stock prices and things like that. So to make one of these requests, we're gonna almost always use HTTP, which is the protocol for transferring text over the internet. It stands for Hypertext Transfer Protocol. And every HTTP request has a few parts. First of all, it has a method. There's a bunch of them, but the ones that you'll probably see the most are get, post, put, patch, and delete. Get is for retrieving information. That would be correspond to the R. The read from CRUD. Post is for creating information. Put and patch both allow us to update information, and then deletes information. So those sort of correspond with our CRUD acronym. And you have to specify which method you're going to do when you make an HTTP request. In addition to that, you have to tell the request where you want to send it, so you need a URL. And the last required part are headers, which are sort of protocol standards, and it provides additional information about the request. Things like, authorization. You might need to be logged in to make a call to an API for security reasons. Like, we don't want to just allow everyone to delete all the data from the database, so you might need to send some authorization along with your request. And then the last part on some of these is a body, which is where we can put data we want to send along with the request. Get and delete don't have bodies, but post, put, and patch might optionally have a request body. And that's where we could send, information about, what we want to create or update. So the general steps for making an HTTP request, similar to our library, the service writer creates their server and they host it on the internet. This could be publicly available for everyone to use. We're going to see a publicly available API shortly. But it might, be privately hosted on an intranet for like a business, so only people or only other programs within their sort of internal internet can use it. Like we talked about with executing arbitrary code that you find on the internet, security is a concern with APIs because you don't know, who is going to use it or how they're going to use it, and you want to sort of limit who can call your web services, just to make sure only people you trust are doing it. So then the consumer, the person who wants to make the call to the web service, uses a client to make that request. A common version of a client is a web browser, and we're going to see an example of a library that makes HTTP calls, but that's going to be our client. And with each of the 3 different types of web services I mentioned, there's different formats. REST has a little bit of flexibility. It can be JavaScript object notation or XML. SOAP, I mentioned, has a strict set of rules about it. So it's XML only, and it's defined in a special file called a WSDL. And there's some pre-processing that goes on before you even make your request. And if you format it incorrectly, it won't let you call the service. So that's kind of nice. It gives you a little confidence that you're making the right request before you submit it. And then GraphQL also has a special way of defining what you can ask for, and it's called a schema. And you can ask the GraphQL server for the schema directly, and it will serve that up to you. So once you make the request, the server handles the request, and it will either return the response or acknowledge the request. And by acknowledge, I mean it'll say, yep, we got it. We're going to do some long-running processing, and we don't have a response for you right now, but you can come get it later. That could be something like uploading a large video file to a website where it might take a long time to do some encoding. And you don't want to keep that HTTP connection open for that whole time. So once the client gets the response back, they parse the response and handle any data that they want to. Here's a diagram of that. It's pretty simple. On the bottom there, we've got different clients. So you could be a server of your own. It could be your tablet, it could be your phone, it could be your desktop computer, but no matter what it is, you make the HTTP request, and we have the server at the top. That's the gray box, and it's backed by a database, and with the little picture of the globe, we know it's hooked up to the internet, so it's sort of listening and doing its processing, and then it responds via HTTP also. All right, now to see an example to put all this in context. Let's say I want to make a fan site for my favorite Pokemon, Pikachu. There is a popular web API that shares information about Pokemon called the Poke API. As you can see, it's pretty popular. They make over 600 million calls every month. So on this landing page here, it claims to be a RESTful API. So that's that representational state transfer style of API. But then on the top right, they're advertising a GraphQL beta version of this API. So I've got an example of both. But this, like we talked about earlier, this is a labor of love, and there's good documentation, and people are enthusiastic about getting the data out there. So there's an endpoint that I'm going to call /Pokemon. As you can see, it is a GET request. It's there on the left in blue. There, just like we saw in the Java doc, there's sort of a description of what this endpoint is going to give us. It says each Pokemon belongs to a specific species, but may take on a variant, which makes it differ from other Pokemon of the same species, such as base stats, availabilities, and typings. So this endpoint /Pokemon is going to give us tons and tons of information about a Pokemon. So it goes on so long it didn't fit in my screenshot, but here's some of the data that we expect. And with both SOAP and REST services, the information that comes back in the response is defined solely by the person or the team that develops the web service. So Maybe I don't care what Pikachu's abilities are. Maybe I just want to know what his height is. But when I make this call, I'm going to get all of that information back, whether I want it or not. So this is a screenshot of some JavaScript code. Like I mentioned, an API is not tied to a specific technology or programming language. We could do the same thing in Java. We could do it in Python. I just like JavaScript, so I wanted to mix it up and show another implementation. So I'm going to use, we need a client to make our HTTP call. There is a popular one called fetch. So and it's distributed as a library. So my first line is importing fetch. And then I make my HTTP call. Like we talked about, every HTTP call has a URL, which is here. So there's /Pokemon, and then I'm passing in the Pokemon I want. This is a GET request, as we saw from the documentation. And headers is a list of headers I'm passing along. So I format the HTTP call, and then I send it to the server, which fetch handles for me, and the server responds, and I'm going to log the data. So the data that comes back, I had to make it super small and delete some redundant stuff, but I got this whole thing back, and that's defined on that documentation that we saw earlier. So, I get the list of abilities, I get the base experience, I get to see what versions of the video game it came out with, all sorts of stuff. And no more, no less than what was described in the documentation. GraphQL, I said, is a query language. So with GraphQL, I can ask for specific pieces of data that I care about, and then the API will only give me that. They won't give me anything extra. So I'm not going to get into exactly what all of this means, but just the way we made our call to the REST service, we're going to make a post to this GraphQL service. So if you'll notice, the URL doesn't have any extra endpoints on it. There's no /Pokemon here, but we are going to do a post and then send in our query and the body of the request. So the last request was a GET, and GET requests don't have bodies. This is a post, so that's why it does have a body. But I am going to ask for the name of the Pokemon. Actually, that's my query. I want the data where the Pokemon's name is Pikachu. I want the name, the height, the ID, and the base experience value. Then the same way, I'm going to make that call, and when I log it, I only get the data that I asked for. I don't get all that extra stuff. So GraphQL is becoming increasingly popular because it allows engineers who make the APIs to just make the data available, and then it lets people who want to consume the API to get the information they care about. So you're saving, there's a cost to transferring data. Like if you're on a cell phone, then there's going to be a big response like the one we saw in the REST API that's going to have a bigger footprint in terms of amount of data transferred. And sometimes as a programmer, you really care about that. So using GraphQL is a way to reduce the payload of your API. So this is a new technology, and it's becoming more and more popular.
Quick question, Sam. So if you use a RESTful API call and you get back all of that data, as an app developer, you're having to filter that and display only the parts of that API call that you want to display, whereas with the GraphQL, You can just customize what you're asking for and only get that back, right?
Yep, exactly. So I didn't have this in my example because I simply logged the whole response, but the last step is handle the response. So if we look at the example, to get these specific values that I wanted in GraphQL, I'd have to do something like response dot, base experience, response dot name, response dot height, or whatever I
Okay.
asked for here. So I would have to manually go get that. Whereas here, I'm specifying I want that stuff.
Up front.
Yeah. So it's,
Okay.
at some point you do have to ask for what you want. But I do think I do prefer to do it up front in this GraphQL style. Good question. All right, we're almost done. The last thing I want to talk about is a remote procedure call. And a remote procedure call allows for the execution of a process on a different machine as if it's running locally. And this is going to sound a lot like a web service because it's typically triggered using a request response process over the internet. And I think kind of the only difference is the use case. We talked about web services being great for database-backed applications, and a remote procedure call is great for running something that's sort of specific to a machine. So we can interact with peripherals remotely, to access a device's webcam. I'm connected to this call over a website called StreamYard, and I had to allow the browser access to my webcam. So usually only my computer specifically has access to my webcam, but now using this remote call, my webcam is accessible to StreamYards. You can also do things like operating system level processes like restart a server, or maybe there's a banking system that runs on a mainframe computer and isn't really accessible. You can trigger routines to run uh, on a system like that using a remote procedure call. So like I mentioned, this does happen over the internet using a request response, and it's the same pattern. It's usually an HTTP request. There are other protocols though, but the client makes a request, the server responds, and usually you wait for the process to finish, but sometimes like with the web services, it could be a long-running process, so the server might just acknowledge you made the request and say, yeah, we're working on it. And there's lots of different implementations, and they're a little harder to demonstrate, so I don't have an example of an RPC specifically. But I think maybe a popular one is developed by Google, and it's called protocol buffers. You see that pretty commonly in industry these days. Questions?
We have no questions in the chat, but I know I threw my questions in as we went. So it's been super awesome to have you share your knowledge with us and your experience. And if you're comfortable with it, if there are ways that if people have questions, or is there somewhere they can reach you, or a way that they can connect with you to ask them later?
Yes, I'm not really on a lot of social media, but I am on LinkedIn, publicly available there. I can share that with you, Valerie, and we can.
Yeah, I can add it to the post when we post this. That'd be awesome.
Great.
All right. Well, thank you so much for your time, and appreciate the knowledge dump that you just gave us.
Yeah, thanks for having me.
Thank you.